Hello everyone, May the 19th. Time flies. Made a little bit progress in the research, but still not good enough. But progress is progress. Alright, let's take a look at today. Evaluate division. You're given an array of variables, variable pairs, and an array of real numbers, values, and an equation, I, and the values, I, represent the equation A divided by B equals the value I. Each AB is a string that represents a single value. You're also given some queries, where queries J represents the jth query, where you must find the answer of Cj divided by Dj. Return the answer to all queries. If a single answer cannot be determined, return -1. The input is always valid. You may assume that a value in the query will not result in division by 0. I remember this question. I remember I used a convoluted way to do it, and I remember the correct way to do this is union find. How does the union find work in this? I do not remember 100%, but let's see. I know this is union find, so we're gonna go with union find. I think AB, right? A divided by B equals 2. What does that mean? That means, did you union A and B together, or? Yeah, because you see A and B, A divided by B equals to 2. So we can say A equals 2B, right? A equals to 2B. So what we can say is, if we take B as the parent, okay? B is the parent, then A equals 2B. So basically it means A and B, if we group it together, right? And B and C, so B and C need to group together. So we shall be able to tell A divided by C, right? Yeah, we shall tell A divided by C. But how do we handle this? You group these together. What are you grouping? You're essentially grouping the values, right? They group together, and yeah, lowercase English letters, which is fine. Lowercase English letters can just be, you know, we can like this 26, right? Basically 26. So we say A and B will be grouped together, but how do we represent this 2? How do we represent this 2? Weights? Okay, if we say we can always use the second one as the, if we use the second one as a root, then the first one will have the weight, or have, like, if you get A and B together, then you say A the value, right? You know, these are a group. The A the value is 2. Then you do B and C need to be grouped together, and then essentially A, B, C, they are all grouped together, have the same root, right? And you say the same root is supposed to be B. It doesn't really matter which one is, right? But it does matter. It does matter. So yeah, so B and C, we need to group them together. So we find which one is the root. And when we find the root, okay, when we find the root, so B is the root. So when we group them together, C the value is not 3. right? Because b is the root. Because we set b to be 1. Yes, we set b to be 1. So when b and c group together, c value needs to be because b divided by c equals 3. So it's b divided by 3. So c become 1 over 3. C become 1 over 3. And then these three has values. A the value I have, b I have value, c I have value, right? Then a divided by c is value. And values are all larger than 0, right? Values are all larger than 0, so I can assume everybody is larger than 0. Then everybody else, the value is going to be minus 1. So when I evaluate things, if some value is minus 1, which means we don't have any value associated with it. Okay, now we have another question. Yeah, these two, so the two values must belong to the same group, right? They must belong to the same group. Yep. That's that. Yeah, I still remember. I think this is one of the early union find that I tried. So union and find. Okay, union find. Oh my god, I just wrote union find. Is that yesterday? This one is slightly different because I need more than, I need parent for sure. This is just a regular play. Parent, I need rank, right? And I also need value. Okay, I also need value, and I'm value gonna set to -1. Okay, def find. Find is the same. I don't think there's anything change in find. This is going to be changed. All right. If they're already together, then that's fine. If they're not together, union, we need to do this, this, and value, and v. V is a float. Okay. Okay, so we say if self.rank px is larger than self.rank py. Okay, then self.parent py shall equal to px. Right, and we need to handle the value. So we say x and y, right? Now we assign the parent of x, right, px, to be the root, and the root is always 1. Okay, the root value is always going to be 1. So when that happens, not really. Well, it depends, right? It depends on whether the value is already there, right? P and Y. So this say so basically this is saying we will trace all the way up to x's root, right? And assign y the root to x, so they belong to the same. But hold a second. I don't think it matters. Seriously, I don't think it matters, because if x and y, if there is a value in x and there is a value in y, then it will always, because they say will not resort. Input is valid, right? The input is valid, so it doesn't really matter. We only need to assign if x and y both are not decided, right? If both are not decided, then their rank, which means they have not been encountered before. That makes sense, right? That makes sense. Otherwise, we can just, assign their values. Now, who is going to be assigned what value? Well, it depends, right? Depends. And it doesn't really matter which one, because you can assign, it doesn't really matter. So I will just, this is the regular code. This doesn't really matter. We just go through the whole thing, px equals py, and else self.parent py equals px, and self.rank px plus equal 1, right? But instead of return here, we need to handle the values. So handle values of x and y. So if self.val x is larger than 0, larger or equal to 0, larger or equal to 0, that means x has been found, then self.value y shall equal to, because x divided by y equals v. So if x is defined, then y shall be x divided by v. If self.value y is larger than or equal to 0, then self.value x shall equal to self.value y multiplied by v. Else none of them, right? Neither has been defined. Then we simply define y equals 1 and self.val x equals self.equal to v. So that's how we handle, right? Then we can just go through equations and values. So we can say for DSU equals DSU 26 letters, right? Then we say for what's that looking for? For AB V in zip equations and values. Okay. Then we say DSU.union ord A minus is 97. Lowercase, hold on. I think it's 97. Yes. 97. Y is ord B minus 97. Value is V. So we do all that, right? Then we say rest equals this. And for query is going to be AB in queries as well, right? If self.find A is not equal to self.find B, which means they do not belong to the same. Then res.append -1, right? Elif self dot, not self, there's no self, Jesus. This is DSU dot value A smaller than 0 or DSU dot value B smaller than 0. So this value is not defined. We can just say, hold on. Can we say if this or this? If they're not equal or they're equal but this, then do this. Else res.append DSU dot val A divided by DSU dot val B. And we'll return result. Give this a shot. Oh, I need to change the checking. Cannot say equal. Has to be is close. Yeah, I'll do that. We'll do that. Okay, so we have equations, values, queries, calculation, equations, values, queries. Huh? Oh, dude, ord A minus 97, ord B minus 97. Hey. AIBI equals ord A minus 97, ord B minus 97. And then this is going to be AI, this is going to be BI. And this is going to be AI, this is going to be BI. And this is going to be AI, this is going to be BI. Where ord expect character, but a string of 2. Huh? Really? ABV. Oh, holy crap. B, C, and CD. Oopsie doozy. Did not see that coming. Oh. Howdy. Oh my. Well, I mean, how'd you handle this? I mean, this can be, what if like A, B, C, D? All right, you have to think about that. If it's A, B, C, D. What if it's A, B, C, D and we can if you give A, B, C, D, I think that's impossible. It's an impossible case because no, it is possible, right? We just assign all of them to be 1. Yeah, assign everybody to be 1, and then it's become possible. So I think what we need to do in this situation is oh, can we put the length can be 5. We can do the single ones first. Okay, so we can sort it. Sort it based on the length. Okay, the sum of the length. So we sorted it. Now if we sort it, it's guaranteed the single ones goes first. Okay, so now if we have a double, right? If we have a double, then we can, check it first. Check if any one of them is already there, right? We check if any one of them is already there. Like if you have A, B, and C, D, should you put them together? If you have AB and CD, you say AB divided by CD equals something. Well, if AB divided by CD is equal to something, hold on, let me try this. Actually, I'm not quite sure. What if I have A, B, C, D? What do you think about this? Yep, they shall all be this, because there's no relationship can be deferred. So this basically just means, because the value of them cannot be determined, because you need to do AB together and CD together, or we can put it this way: if we cannot like if I have A and B, that's still not going to be working, right? If I say I have A, I have B, right? Doesn't matter. If in this, it's still not going to work. But AB can work, like this one can work, because I know A divided by B equals to 2. But knowing A and B, I have the value. I know C times D, okay? I know C times D. I know C times D. Holy moly, C times D. What you're saying is if I do A and CD, this shall work. Because A is 2, B is 1, okay? AB is 2, so I know CD is 2 divided by 3. So this is A 2 divided by 2 divided by 3. So this should be 3. Nope. it gives me a -1. Huh. So what you're saying is, yeah, definitely get the single ones first. And then when we hit the multiple ones, we get rid of whatever we can. Okay? We get rid of whatever we can. And then we have some remaining. And if we have a double, then we have to record the double. Yeah, there's no other way. We have to record the double or triple. Alright, it doesn't really matter. Because in this case, this does not work. I thought it does. Yeah, I mean, it does not, because a equals 2b, right? A equals 2b. So this is 2b squared. 2b squared equals CD. Hold a second. 2b squared equals CD. Wait. Let's write it out. We're saying A equals 2b, right? And AB equals 3CD, right? And we want to know if we can compute A divided by CD. So if we do A divided by CD, that equals to 3 divided by B. But we do not know B. Alright, B is, so this one, I can know CD. So 3 divided by B. B is what? B is A divided by 2. So that's that. So that's all we can know, right? Is A squared. A squared divided by CD equals 6. Wait. Does that mean multiply? Let me look again. Given an array, equation of an array of real numbers is a string that represents a single variable. Oh, scared the hell out of me. I was so scared. So scared. Okay, so now we just need to figure out a way. To represent these two with a value. Why bother? We just change this. Change this to what? Change this to a dictionary. Everybody's parent is itself. Okay? Then we don't have initiation. What about the rank? Dear Lord. Or you figure out a way to get a int out of this, but I think collections, default dict. I think it's time to use default dict. Well, the first one is not default dict. This one is default dict int, and this one is default dict lambda -1. So, it shall be itself, right? Everybody's parent shall be itself. How do I do that? Well, we can do it this way. If self.parent x, if x not in self.parent x equals x, right? Then we do this. Oh, it'll be very interesting. Rank. Well, initial rank will be 0, right? Like we can do because it's default dict. Parent. Rank. Value. Holy crap, this might actually work. Then we don't need to OR. It's just going to be A and B. Oh. This is just going to be A and B. Oh. Well, I thought we have to handle... I thought that means a multiplication. But it's not a multiplication. It's a single value, right? You have to read it carefully. Represents a single variable. Look, it was a bloodbath last time. Oh my god. Oh. Still bloodbath, huh? Dear me. Got a little bit error here. How many did we pass? 16. Probably some, I don't know, typo. What else? Oh, we're so confident. I thought I got it this time. First shot. Yeah, that's okay. That's okay. Let's take a look. A, B, E, F, B. Aye, that should be right. But why is it not right? First one's right. Second one is not right. AF, A, B, E, F, B. Everybody is connected, right? Everybody's connected. Let's take a look at DSU.values. The vowels. Wait, vowel. A, B, E, F. A, B, E, F. Oh, damn. I know. I think I made the same mistake last time as well. So when AB is done, when EF comes in, I assign E and F, I assign one of them to be 1. And then I do B and E, right? Now when I do B and E, here's the problem. Because B is 1, yep, that is the problem. How do we resolve this problem? Well, ideally, after you do B, you want to do B, right? And do E, and then you want to see anyone that has... Are you saying we need to treat this as a graph? I think that's what it's saying. We should treat it as a graph. A to B has a value 3.4. It's a directed graph. A to B has this value. E to F has this value. So we start from the first. Then we do this, right? And then we do B and we go to E. Right, from E we go to F. So we traverse everything. But how do we know we finished traversing everything? Well, that is the safest way. Okay, let's graph this thing. Graph equal to default dict a list. So for this, graph a dot append bv Okay, so blah 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 or done, and then visited set when the DFS is stuff. DSU, oh, doesn't even need this n, useless. Now we're gonna say def DFS, right? DFS of current node is gonna be a str, and then we don't return anything. Okay. We say if node is not in visited, so we have visited dot add node, then we're gonna visit for child in graph. Oh, child v in graph node. Okay, in graph node. What do? We do because it's node to children, right? So we need to DSU dot union node to child with v. Okay. Once we're done with DFS child, and that's it. Then we do this. Then we do this. Try it. What the hell? That's even worse. I don't get anything. Oh, I didn't DFS it. Dear Lord. For node in graph DFS node. Dictionary change size. How does dictionary change size? Huh? DFS node. Where? Where did we change size? What are you talking about? Dictionary changes. I didn't delete. I didn't do anything. That is weird. What do you mean? Take a look. Okay. Okay, keys. Nope, it doesn't work. Didn't change. I have no clue what the hell happened. I go from A to B, A to B, to E, to F, okay, let's don't do this. What? What did I do wrong? I cannot do this? Oh, this is not right. Values. Wait, no, that's not values. Graph node is, no, graph node is already a list. Huh? That does not make any sense. Okay. That does not make any sense, man. Which dictionary are you talking about? Probably is this dictionary. But why would it matter? Why would it matter? I don't know. I don't know. Hold on. How about I just say A? I don't have B, I have E. Oh! I mean, the result's still not right, but we have some other issues now. The second one is not right, but hold on. The last one. Graph. Oh. Damn. There we go. All right, so this is right, but our value is still not. All right, what's the problem now? Okay, A, B is fine, and then next one we go B and E, right? B is 1, E, so B divided by E equals 2.3, so E should be 1 divided by 2.3. I hope that's 1 divided by 2.3. I'm not sure. 1 divided by 2.3. 0.434. That is correct. The next one is E and F. So E divided by F equals 1.4. So F shall be E divided by 1.4. Right? So this divided by 1.4 shall be 0.3. 0.31. Yes, 0.31. And my answer, first one's correct. Second one, oh, it's correct. It's correct. It's correct. This is all for a result answer in zip result answer, we need to do mass dot is close RNA. Oh, res ans. It's not close? What? Oh, first of all, I don't need this one anymore. RA mass dot is close RA. You gotta be kidding me. Is close. That is too low. Let's get it higher. Is close. To the 3. Okay. All right, let's do this to the 3. There we go. There we go. All right. Try it again. No. What? Did not improve at all. Last time is two rounds. This time is 2 rounds again. The hell? Oh, this is a tough one. 1, 2, the last one. What's the last one? Last one is A divided by Z. Okay. Okie dokie, let's see what's going on. Let's see what's going on. Do we have... Okay, we have A, B, 2, C, B, 3, D, B, 4, W, X, 6, 5, right? 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, 8. Y, X, 6, Z, X, 7, W, D, 8. Okay, A, B. So A is 2, B is 1, C is 3, D is 4, and X is 1, W is 5, Y is 6, Z is 7, and W and D W and D. Hold on. W and D. Oh, W and D. W has a value, right? D has a value, but they all based on somebody else. Because W, so someone has to increase. So W shall equal to A times D. Now D is 4, right? So W shall be 32, right? So everybody shall times 4. So this one shall be 4. This one shall be 24. This shall be 28. And what's the last one that we're supposed to do? A divided by Z. So it should be 2 divided by 28. 2 divided by 28. No. No, times 8. 8 times D. Oh, hold on. 8 times D. No. Oh, that's not right. What are you doing, man? We have eraser. Let's erase. Now the problem is, if we done all this and we immediately do W to D, right, then we'll get a right value for W and everybody else will be correct. But we have to handle this. So we do A to B, all right, we get some value, and next one we do, yeah, it's gonna be W, and we do W to X, right, and then we set X equal to 1. Now what happens is when we do something, we have to update the value, right? We have to update the value. If both value, so yeah, so here X is 1, right? W is 5, this is 6, this is 7. So now we have W and D, right? W and D. So we have W is 5, D is 4. But now we say W shall equal to 8 times D, right? Now these two values is there, and then there is not equal to, so we need to update. Now how do we update? Well, we update by set D, right? It should be 4. D is 4, right? So we shall look at, so W need to be a value. So W need to be 32. But original W is 5. So everything associated with the W shall be changed, shall be 32 divided by 5, shall be scaled by 32 divided by 5, which means this is gonna be 32, and everybody associated, everybody's in the same group, right, need to multiply it by 32 divided by 5, right? 32 divided by 5, 32 divided by 5. So eventually we're going to do A divided by Z. So it's going to be 2 divided by 7 times 32 divided by 5, which is 16. So it'll be 5 divided by 16 times 7. Okay, let's check if it's correct. 5 divided by 16 times 7. 0.04464. So the problem, everything is fine, okay? The problem is handle this, right? Now we need to be smarter. We have to be smarter to handle this. how do we handle this? Well, we shall say if this is larger than 0 and self.val y is smaller than 0. Perfect. If and self.val x smaller than 0. Perfect. Elif self.val x smaller than 0 and self.val y smaller than 0. Right. As long as one of them is smaller than 0, then we can assign whatever value we want. Else, so both x and y already have value, right? We need to check. We need to check whether one of them need to be scaled. Well, essentially, whether x needs to be scaled. Okay, so this is the complex part. So what we need to do is we need to check, right? How do we check? So we know x, so we say elif, okay, elif self.val x divided self.val y math.isClose v. If it's not close, okay, then we're going to say this equals to 1e, maybe we do 4. Okay, so if it's not close, what if it's not close? But we need to scale. But we need to scale x and all the values, all the numbers associated with x. Okay. So ratio shall equal to, so it's not close, right? So ratio shall equal to v, okay, times self.val y divided by self.val x. And then we need to go, I know px, right? So we need to go through everything. So we need to say for key value in self.parent.items, right? If, oh, now v, so shall be number and p, right? Parent in this. If parent is equal to px, then self.val number times equal to ratio. So into scale. Okay. With this, no, that's not fair. That is not fair. Is this not right? V, so x, y, and v. Self.val x, self.val y. I need to examine this. Okay, WD8, 5, and 4. Yeah. Ratio shall be v is 8 times y is 32 divided by 5. So the ratio is also right. the ratio is correct, right? The ratio is correct. I think I know. So what we need to do is, they already handle this part. So what we need to do, we got a ratio, right? We just need a num. We don't care about its parents. Okay? We don't care about the parents for now. We just need a num. And then if p does not p, self.find symbol, okay? Symbol, if it's equal to, then the value symbol. No! What? Gotta be kidding me, man. You're killing me. You're absolutely killing me now. Every single one. Huh. You scale every single one, but you're not supposed to scale every single one. I mean, they are. Right? They are all connected because D to B, so say D and B is connected. And W and D, right? But A and B connected. C and B, so ABC connected. ABCD connected. Yeah, WD, so they're all connected. But we're not supposed to change the ones associated with D. What are you saying? Why is this not right? Yeah, because D is not supposed to change A, B, and C. But how do we know which side is which? They're all connected now. Yeah, they're all connected. They're supposed to have the same value. Yeah, because X has its own value initially, right? Now I say I'll pick D. So before. So this is the connection of two groups that initially was not connected. Okay? So initially A, B, C, D are connected. And then W, X, Y, Z are connected. Now we establish a new connection between the two. Now if that happens, are you saying that we shall always do this first before connecting them? Is that what you're saying? So that means we need to connecting the two. But we'll handle it first. So you're saying we shall handle them first. Because when you handle, but these two are not connected. So if you set one of them to be the base and the other one will be will follow this, right? Then we can connecting them. This might actually be right. Hold on, let's not print this. Let's not print this. Yeah. Oh, is this in my nightmare? Damn. This must happen before union because we only want to update the value, right? Only want to update value in the current subgroup, and then union the two subgroups. If we union first, right, then the update happens to the entire, right, happens to both subgroups, which we do not want, since one of the subgroup serves as the base. Oh, one more time. Damn, man. Look at the April 30th. My first shot was right. I must have used some suboptimal solution. Man, 2 days I wasn't able to keep going on. Damn it. Another. I knew it is union find, but I forgot how complex the value update is during union find, during the union. I mean, in fact, if we do it this way, we probably don't even have to traverse like this. What do you think? Yeah. It doesn't matter because we will update the value. Okay, so what are you saying? I am saying we do this at the top. Don't do this. Don't do this. Basically, don't do this. And don't do any of this. We simply do dsu.union abv. That's it. Yeah. No need even to do that. Yeah. There are two right? Now the main issue is when two numbers, okay, when two symbols have already been assigned values and they need to be union. What do we do? The answer is, the answer is one of them will serve as the base and the other has to scale. But more than that, all the symbols originally associated with the scaled symbol need to be scaled as well. And all of this scaling must take place before union. Yeah, this is the difficult part. And I believe with this, it's going to be faster. So we don't have to do the other. It's all right. Whatever it is. All right. Oh, Jesus. Okay. So this is the previous method. Graph. Ratio. You see the ratio? Yeah. That's what we need to do. I don't think I did this myself. Arbitrarily force all nodes union find point to parent Y as their new parent. This is much easier. Px, Py, okay. We have the ratio. Default value is 1. Okay. And everybody will use Py as the parent. Okay. Then if everybody use Py as the parent, this actually solves a lot of the issue. We don't have to go through all this. If everyone use the same thing as the parent, and each time we do it, we update every single thing. Yeah. We take Py as the parent, we have the ratio, so anything that's with px needs to be updated. You see here, right? This is before we connect them. We find it first. This is before we connect, right? Before we connect. Oh, I think I know. It's DSU1. We need a DSU2. Fine is fine. This is union. Now, here is a trick. We always assign py as the root, as the parent. Okay, we always assign py as the parent. It does not matter what. So, then we can compute a ratio, right? We can compute a ratio. We'll update all the values, right, associated with x. Yeah, because we say y is the root. Y is the parent of x. So x is relative to y. Or we say, or we always consider, right? Consider x relative in terms of y. Right. Then we update all the values associated with x in terms of y. Then we can just say for symbol, right? Symbol and p in self.parent.items before the current union. Right? Self.value is symbol times equal to ratio, and self.parent symbol we assign to y. From the solution 1 year ago. The trick in union is to always designate py as the parent and then update the entire cohort and update the entire cohort associated with px. Hold on. If p is equal to px, update the value of the entire cohort associated with px in terms of the value of y. Everything else is the same. DSU2. Yeah, it's right. The first one. Oh, yeah, if this and if if a or a not in DSU.val or b not in DSU.val. I mean, why can't I just take them out? Yep. All right. Yeah, pretty bad. Pretty bad. All right, that will be it. Man, we did pretty bad today. I'll see you guys tomorrow. Adios.